Alright, in the last video we talked about some rules or some guidelines that will help us in writing Lewis dot structures for compounds. We talked about, halogens don't like to form double or triple bonds, about how carbon loves to be the central atom. And we also talked about the metallic nature of the periodic table as you move left and down, and how usually your central atom likes to be the more metallic atom. So that being said, let's go ahead and start doing some actual problems here with these. So I've got one up here. I have SF2. So we know that from the periodic table, let me just peek back up here real quick, that sulfur is more metallic than fluorine, because you go left and down as it becomes increasingly more metallic. So sulfur is going to be our starting atom, our central atom. We'll do sulfur and fluorine. Both the fluorines are going to be, and it doesn't matter which side you write them on. You can write one up here. I could write this like this. I could write it like this, because these things are all moving in time and space. They're constantly shifting directions anyway. Maybe this one's going that way and then coming back up again right there. They're constantly moving in space. So I don't want to waste space with that right there, but I just wanted to give you a quick idea that it really doesn't matter how you write these. In fact, it's multiple different ways that these can be written. Ultimately though, and actually let me do fluorine here and say yellow. That way it's just a little bit easier to see. Everything's going to be connected by at least a single bond. So we've got two single bonds right there, and this is kind of the same process that you're going to go through every time you write a Lewis dot structure. So everything's connected by single bonds. So we've got our two fluorines connected to the sulfur by single bonds. Now what I like to do at this point in the game is kind of go and add up all the valence electrons that I'm going to be working with. So I have two fluorines. Fluorine has 7 valence electrons because it's right here. And I've got two fluorines, so that's going to make it 14 total valence electrons. So I've got 14 for fluorine. And then sulfur, I forgot I have this periodic table over here also. Let me move the dictionary out of the way. Sulfur has 6 valence electrons because it's in 1, 2, 3, 4, 5 group 6. So it has 6. Add that up together, and that's 20 total valence electrons, right? If I don't use a total of 20 valence electrons whenever I draw this out, I've done something wrong. So I'm just going to kind of go through and fill this in, just using up the rest of my valence electrons. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I've just kind of aimlessly gone through and added my valence, or added my remaining 20 electrons, just kind of not quite helter-skelter, I guess you would say, but just filling them in at random. No rhyme or reason on how I did that. Let's just take a look now if that worked out. I have fluorine, which wants to have 8 valence electrons. It's sharing those electrons. And then I've got the second fluorine sharing these valence electrons. And then we have sulfur, which is going to be sharing these electrons right here. With sulfur we have 2, 4, 6, 8. Fluorine we've got 2, 4, 6, 8. The second fluorine we have 2, 4, 6, 8. So it ended up working out that way. This was one of those situations where we didn't have to change to double bonds or even triple bonds on any of these, which kind of makes sense that we wouldn't have had to do that, because fluorine is a halogen and halogens do not form triple bonds. So that was kind of a gimme for us, that all we have to do is put sulfur down here, slap them together with single bonds, fill in the electrons, and then we're done, right? This kind of makes life a little bit easier whenever you follow these rules. Let's do a different one. Let's do, and this is maybe even more of a popular one, or actually I'll save that one for another video. Let's do CH4. Alright, now we know that carbon generally likes to be the central atom, and you can almost bet that it almost always likes to be the central atom when it's bonding with hydrogen. So we have carbon, and then we have 4 hydrogen molecules. So we've got hydrogen up here, hydrogen over here, got a hydrogen over here, got a hydrogen, I did that, let me do red, get hydrogen over here. So 4 hydrogens, 1 carbon. Alright, next thing, and we know that they're all put together by at least single bonds. So let's just draw the bonds in here. We know it's at least got single bonds. Single bonds. Now all we need to do is add up all of our electrons. We know that hydrogen has 1 valence electron. There's 4 of them, so we're going to have 4 electrons for hydrogen. And we know that carbon, let me pull up the periodic table here for you, carbon is in group 4, 1, 2, 3, 4. So it has 4 valence electrons. So that's 4 for carbon, so that's 8 total. If we don't use 8 total electrons whenever we write out our Lewis dot structure, we've done something wrong. So let's just take a look and see what we've got here. We've got 1, 2, 3, 4, 5, 6, 7, 8, all 8 electrons, so that ended up working nicely. We know that hydrogen likes to only form 2. Looking good so far. And that carbon likes to have 8. And carbon is going to share all of these right here. And there's 2 electrons right in here. It's kind of hard to see them now. But it's sharing those. So I've ended up working out. So I've got 8 valence electrons on there. You may be saying, well, hey, this is kind of easy. Well, let's step it up a notch here. Let's do, and this is the one I was going to do earlier. This is kind of the more, I guess you could say, popular compounds, especially among today's youth. Or actually, I'm about out of time, so I'm just going to save that one for the next video. But anyway, thanks for watching. In the next video, we're going to talk about more complex, both carbon chain molecules, writing out Lewis dot structures for those, and other molecules as well. And we're just going to get increasingly more difficult and use these same guidelines that we talked about in the previous videos to make life a little bit easier in writing these out. So thanks for watching.